The National Electrical Code 2005 introduced several significant changes to arc flash requirements. These changes aim to enhance electrical safety by providing clearer guidelines and more stringent measures for protecting personnel from arc flash hazards. One key aspect of the NEC 2005 is the introduction of new definitions. The code defines several new terms related to arc flash. These include arc flash boundary, which is the distance from energized equipment within which a person could receive a second-degree burn if an arc flash occurred. Arc flash hazard is defined as a dangerous condition associated with the release of energy caused by an electric arc. Arc flash protection refers to the methods and equipment used to minimize the risk of injury from an arc flash. Another significant update is the requirement for arc flash hazard analysis. The NEC 2005 requires all new and existing electrical installations to perform an arc flash hazard analysis. This analysis is crucial for identifying potential arc flash hazards and determining the level of protection needed. The analysis must identify potential arc flash hazards and calculate the incident energy at various locations. Incident energy is the amount of thermal energy that a worker could be exposed to during an arc flash event. The calculation of incident energy helps in selecting appropriate personal protective equipment, or PPE. The NEC 2005 also includes new arc flash protection requirements. The code mandates that all personnel working on or near energized equipment must be protected from arc flash hazards. Protection measures include the use of insulated clothing, arc flash suits, and face shields. Insulated clothing provides a barrier against electrical shock, while arc flash suits protect against thermal burns. Face shields protect the face and eyes from arc flash debris and intense light. Furthermore, the NEC 2005 places increased emphasis on lockout-tagout procedures. Lockout-tagout is a safety procedure used to ensure that electrical equipment is de-energized before any work is performed. The code requires that all electrical equipment be locked out and tagged out before any work is performed. This prevents accidental energization of the equipment, which could lead to an arc flash. Cal OSHA, the California Occupational Safety and Health Administration, plays a role in enforcing electrical safety standards in California. Cal OSHA typically adopts the NEC with a few modifications. As of 2023, Cal OSHA has not adopted the NEC 2005, but it is expected to do so within the next few years. It is crucial to stay informed about Cal OSHA's adoption of the NEC to ensure compliance with local regulations. To ensure compliance with the latest arc flash requirements, several recommendations can be followed. Firstly, perform an arc flash hazard analysis using the latest version of IEEE Standard 1584, which is 2018 or later. IEEE Standard 1584 provides guidance on how to perform an arc flash hazard analysis and calculate incident energy. Secondly, implement appropriate arc flash protection measures based on the results of the analysis. This includes selecting the right personal protective equipment, establishing safe work practices, and providing training to employees. Thirdly, train all personnel on arc flash hazards and the proper use of personal protective equipment. Training should cover the identification of arc flash hazards, the selection and use of PPE, and the procedures for working safely near energized equipment. Fourthly, monitor Cal OSHA's website for updates on when the NEC 2005 will be adopted. Staying informed about regulatory changes is essential for maintaining compliance. It is important to note that arc flash hazard analysis and protection measures are complex and should be performed by qualified electrical engineers. These professionals have the expertise to assess arc flash hazards, calculate incident energy, and recommend appropriate protection measures. They can also provide training and guidance to ensure that workers are protected from arc flash hazards. Arc flash incidents can result in serious injuries, including severe burns, blindness, and even death. Therefore, it is essential to take arc flash safety seriously and implement the necessary measures to protect workers. By following the guidelines in the NEC 2005 and consulting with qualified electrical engineers, facilities can create a safe working environment for their employees. Firstly, understanding arc flash. Arc flash is a type of electrical explosion that occurs when a short circuit passes through the air between energized conductors. This can happen due to a variety of reasons, such as accidental contact with tools, equipment failure, or insulation breakdown. The resulting explosion can generate intense heat, pressure waves, and molten metal, posing significant risks to anyone in the vicinity. Secondly, the importance of NEC compliance. Compliance with the National Electrical Code, or NEC, is crucial for ensuring electrical safety. The NEC provides comprehensive guidelines for the safe installation and maintenance of electrical systems. By adhering to these guidelines, facilities can minimize the risk of electrical hazards, including arc flash. Thirdly, key updates in NEC 2005. The NEC 2005 introduced several key updates related to arc flash safety. These updates aim to provide clearer guidance and more stringent requirements for protecting workers from arc flash hazards. These updates include new definitions, requirements for arc flash hazard analysis, and new arc flash protection requirements. Fourthly, defining arc flash terms. The NEC 2005 introduced several new definitions related to arc flash. These definitions help to clarify the terminology used in arc flash safety and ensure that everyone is on the same page. The definitions include arc flash boundary, arc flash hazard, and arc flash protection. Fifthly, arc flash boundary explained. The arc flash boundary is the distance from energized equipment within which a person could receive a second-degree burn if an arc flash occurred. This boundary is determined based on the incident energy level at a particular location. It is important to maintain a safe distance from energized equipment to avoid being within the arc flash boundary. Sixthly, understanding arc flash hazard. An arc flash hazard is a dangerous condition associated with the possible release of energy caused by an electric arc. This hazard can occur when working on or near energized equipment. It is essential to identify and assess arc flash hazards before beginning any work. Seventhly, implementing arc flash protection. Arc flash protection refers to the methods and equipment used to minimize the risk of injury from an arc flash. This can include the use of personal protective equipment, or PPE, engineering controls, and administrative controls. The goal is to reduce the likelihood of an arc flash and to protect workers if one does occur. Eighthly, the role of arc flash hazard analysis. The NEC 2005 requires all new and existing electrical installations to perform an arc flash hazard analysis. This analysis is crucial for identifying potential arc flash hazards and determining the level of protection needed. The analysis must identify potential arc flash hazards and calculate the incident energy at various locations. Ninthly, calculating incident energy. Incident energy is the amount of thermal energy that a worker could be exposed to during an arc flash event. This energy is measured in calories per square centimeter. The calculation of incident energy helps in selecting appropriate personal protective equipment, or PPE. Tenthly, selecting appropriate PPE. The selection of appropriate personal protective equipment, or PPE, is based on the incident energy level at a particular location. PPE includes items such as arc-rated clothing, face shields, gloves, and footwear. It is essential to select PPE that is rated to protect against the expected incident energy level. 11thly, arc flash protection requirements. The NEC 2005 includes new arc flash protection requirements. The code mandates that all personnel working on or near energized equipment must be protected from arc flash hazards. This protection can be achieved through the use of PPE, engineering controls, and administrative controls. 12thly, using insulated clothing. Insulated clothing provides a barrier against electrical shock. This type of clothing is typically made from flame-resistant materials that do not conduct electricity. It is important to wear insulated clothing when working on or near energized equipment. 13thly, wearing arc flash suits. Arc flash suits protect against thermal burns. These suits are made from multiple layers of flame-resistant materials that are designed to withstand the intense heat of an arc flash. It is essential to wear an arc flash suit when working in areas with a high risk of arc flash. 14thly, utilizing face shields. Face shields protect the face and eyes from arc flash debris and intense light. These shields are made from impact-resistant materials that can withstand the force of an arc flash. It is important to wear a face shield when working on or near energized equipment. 15th, lockout-tagout procedures. The NEC 2005 places increased emphasis on lockout-tagout procedures. Lockout-tagout is a safety procedure used to ensure that electrical equipment is de-energized before any work is performed. This prevents accidental energization of the equipment, which could lead to an arc flash. 16th, de-energizing equipment. De-energizing equipment involves disconnecting it from its power source. This can be done by opening circuit breakers, disconnecting fuses, or removing power cords. It is essential to verify that the equipment is de-energized before beginning any work. 17th, locking out equipment. Locking out the equipment involves placing a lock on the disconnecting means to prevent it from being re-energized. This lock should be unique to the person performing the work and should only be removed by that person. 18th, tagging out equipment. Tagging out equipment involves placing a tag on the disconnecting means to warn others that the equipment is being worked on. The tag should include the name of the person performing the work, the date, and the reason for the lockout-tagout. 19th, Cal-OSHA's role. Cal-OSHA, the California Occupational Safety and Health Administration, plays a role in enforcing electrical safety standards in California. Cal-OSHA typically adopts the NEC with a few modifications. It is crucial to stay informed about Cal-OSHA's adoption of the NEC to ensure compliance with local regulations. 20th, staying informed. Staying informed about regulatory changes is essential for maintaining compliance. Facilities should monitor Cal-OSHA's website for updates on when the NEC 2005 will be adopted. They should also attend industry conferences and workshops to stay up to date on the latest arc flash safety practices. 21st, performing arc flash hazard analysis. To ensure compliance with the latest arc flash requirements, several recommendations can be followed. Firstly, perform an arc flash hazard analysis using the latest version of IEEE Standard 1584, which is 2018 or later. This standard provides guidance on how to perform an arc flash hazard analysis and calculate incident energy. 22nd, implementing protection measures. Secondly, implement appropriate arc flash protection measures based on the results of the analysis. This includes selecting the right personal protective equipment, or PPE, establishing safe work practices, and providing training to employees. 23rd, training personnel. Thirdly, train all personnel on arc flash hazards and the proper use of personal protective equipment. Training should cover the identification of arc flash hazards, the selection and use of PPE, and the procedures for working safely near energized equipment. 24th, monitoring Cal-OSHA. Fourthly, monitor Cal-OSHA's website for updates on when the NEC 2005 will be adopted. Staying informed about regulatory changes is essential for maintaining compliance. 25th, consulting engineers. It is important to note that arc flash hazard analysis and protection measures are complex and should be performed by qualified electrical engineers. These professionals have the expertise to assess arc flash hazards, calculate incident energy, and recommend appropriate protection measures. 26th, preventing injuries. Arc flash incidents can result in serious injuries, including severe burns, blindness, and even death. Therefore, it is essential to take arc flash safety seriously and implement the necessary measures to protect workers. 27th, creating a safe environment. By following the guidelines in the NEC 2005 and consulting with qualified electrical engineers, facilities can create a safe working environment for their employees. 28. Understanding the NEC 2005. The National Electrical Code 2005, or NEC 2005, is a comprehensive set of standards for the safe installation of electrical wiring and equipment. It is updated every 3 years to reflect the latest advancements in technology and safety practices. Understanding the NEC 2005 is essential for anyone working with electrical systems. 29th. Addressing arc flash hazard. Arc flash hazards are a significant concern in the electrical industry. Arc flash incidents can occur when electrical equipment malfunctions or when workers make mistakes while working on energized equipment. These incidents can result in serious injuries or fatalities. 30th. Focusing on safety. Safety should always be the top priority when working with electrical systems. By following the guidelines in the NEC 2005 and implementing appropriate safety measures, facilities can minimize the risk of arc flash incidents and protect their workers. 31st. Performing regular inspections. Regular inspections of electrical equipment can help to identify potential hazards before they lead to an arc flash incident. Inspections should be performed by qualified personnel and should include a thorough examination of all electrical components. 32nd. Maintaining equipment. Proper maintenance of electrical equipment is essential for preventing arc flash incidents. Equipment should be maintained according to the manufacturer's recommendations and should be repaired or replaced as needed. 33rd. Using proper tools. Using the proper tools for the job is essential for preventing electrical accidents. Tools should be insulated and should be in good working condition. Workers should be trained on how to use tools safely and effectively. 34th. Wearing appropriate clothing. Wearing appropriate clothing can help to protect workers from electrical hazards. Clothing should be made from flame-resistant materials and should fit properly. Workers should avoid wearing loose clothing or jewelry that could get caught in electrical equipment. 35th. Following safe work practices. Following safe work practices is essential for preventing arc flash incidents. This includes de-energizing equipment before working on it, using lockout-tagout procedures, and wearing appropriate personal protective equipment. 36th. Providing training. Providing training to workers on electrical safety is essential for preventing accidents. Training should cover the identification of electrical hazards, the use of personal protective equipment, and the procedures for working safely near energized equipment. 37th. Reviewing safety procedures. Safety procedures should be reviewed regularly to ensure that they are up to date and effective. Workers should be involved in the review process and should be encouraged to provide feedback. 38th. Documenting safety procedures. Safety procedures should be documented and made available to all workers. This ensures that everyone is aware of the procedures and can follow them consistently. 39th. Enforcing safety procedures. Safety procedures should be enforced consistently. Workers who violate safety procedures should be subject to disciplinary action. This helps to create a culture of safety in the workplace. 40th. Promoting a culture of safety. Promoting a culture of safety is essential for preventing electrical accidents. This involves creating a workplace where safety is valued and where workers are encouraged to report hazards and concerns. 41st. Conducting job hazard analysis. A job hazard analysis, or JHA, is a systematic process for identifying potential hazards associated with a particular job or task. The JHA should identify all potential hazards, assess the risks associated with each hazard, and develop control measures to eliminate or reduce the risks. The JHA should be documented and reviewed regularly. 42nd. Performing risk assessments. A risk assessment is a process for evaluating the likelihood and severity of potential hazards. The risk assessment should consider all potential hazards, including electrical hazards, and should identify the control measures needed to mitigate the risks. 43rd. Establishing control measures. Control measures are actions taken to eliminate or reduce the risks associated with potential hazards. Control measures can include engineering controls, administrative controls, and personal protective equipment. Engineering controls are physical changes to the workplace that eliminate or reduce hazards. Administrative controls are changes to work practices or procedures that reduce hazards. Personal protective equipment, or PPE, is equipment worn by workers to protect them from hazards. 44th. Verifying control measures. Control measures should be verified to ensure that they are effective. This can be done through inspections, audits, and observations. If control measures are not effective, they should be modified or replaced. 45th, communicating hazards. Hazards should be communicated to workers so that they are aware of the risks and can take appropriate precautions. Hazards can be communicated through training, signage, and safety meetings. 46th, reporting incidents. Incidents, including near misses, should be reported so that they can be investigated and prevent similar incidents from occurring in the future. Incident reports should include a description of the incident, the causes of the incident, and the corrective actions taken to prevent future incidents. 47th, investigating incidents. Incidents should be investigated to determine the root causes and to identify corrective actions. Incident investigation should be conducted by qualified personnel and should involve all relevant parties. 48th, implementing corrective actions. Corrective actions should be implemented to prevent similar incidents from occurring in the future. Corrective actions can include changes to work practices, procedures, or equipment. 49th, monitoring corrective actions. Corrective actions should be monitored to ensure that they are effective. This can be done through inspections, audits, and observations. If corrective actions are not effective, they should be modified or replaced. 50th, reviewing the safety program. The safety program should be reviewed regularly to ensure that it is up to date and effective. The review should include an evaluation of the program's goals, objectives, policies, and procedures. The review should also consider feedback from workers and other stakeholders. Finally, continuous improvement. Continuous improvement is essential for maintaining a safe workplace. Facilities should strive to continuously improve their safety programs and to identify and eliminate potential hazards. The key to ensuring electrical safety and compliance with arc flash requirements lies in a multifaceted approach, encompassing thorough hazard analysis, appropriate protection measures, comprehensive training, and continuous monitoring of regulatory updates.